Today's lesson is on arithmetic sequences and geometric sequences. And what we want to get out of this is basically, can we tell the difference and can we tell when something doesn't belong in either of these? So let's start with what a sequence is. Really, all it comes down to is that it is a list of numbers. They're often, almost always, ordered, so the order that it matters, and follow a pattern. So you might think of a sequence as like 1, 2, 3, 4, 5, like that's a sequence, or 6, 6, 6, 6, 6, 6, 6, 7, whatever, like that's a sequence. So, but there's some sequences that are a little bit more special than that. So arithmetic sequence, here's an arithmetic sequence. That's baby Seal. He's fine. And this one you'll notice 4, 7, 10, 13, 16, 19, 22. Hopefully you can start seeing a pattern there. In this case, the sequence is that every single one is adding 3. So even to 19 to 22, it's adding 3. The whole thing, the rule is adding 3, which means the next number would be 25, and you could even continue it beyond that. So that's one kind of sequence. You can also have a sequence that's decreasing, like this purple one here. In this case, the pattern is that it is decreasing, but in this case, you could think about this as like subtracting by a half, or you could think that I'm adding a negative a half. So it's going down by a half, down by a half, etc., etc. So the next number here would end up being 7. An important part about arithmetic and geometric sequences is if you have enough terms, you can figure out what the next term is. I should be eventually able to ask you what's the 50th term here. We'll get to that later. Geometric sequences. Sorry, getting ahead of myself. My bad. So arithmetic sequences are patterns that grow or shrink by the same amount, meaning that every single time here I added 3, every single time here I subtracted by a half, and you're always adding or subtracting. So you'd never in an arithmetic sequence say plus 3 plus 4 plus 3 plus 2. That's not what an arithmetic sequence is. There are other sequences that might do that, but arithmetic sequences, adding the same amount or subtracting the same amount. Geometric sequences, here are 2 examples. 8, 4, 2, 1, a half, a fourth, an eighth. What's happening here is that every single time you could think about that I am dividing by 2, or if you wanted to, it's the exact same thing. You could think that I'm multiplying by a half. But the idea here is rather than adding and subtracting, now we're dividing or multiplying. So 1 divided by 2 is a half divided by 2 is a fourth, etc. And in the yellow one, we're increasing. So again, you can decrease or you can increase. Here I'm just multiplying everything by 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 81, or 20 times 3 is 81. So a geometric sequence is one where a pattern grows or shrinks by a fixed multiplier. So in this case, dividing by 2. In this case, you could say I'm multiplying by 3 for every single one of these, ... and then ... here. Okay, so hopefully that explains a little bit about it. Don't get too caught up, but by all means ask me if you have questions. And then the Desmos activity that's linked for today, you do a little bit of practicing of mashing arithmetic and geometric sequences. And yeah, hope you're doing great. Let me know if you have questions.